A patient requires 1,000 ml of saline to be delivered over 8 hours. The drop factor is 20 drops per ml. Calculate the drip rate. If we're going to use the VT/dF/1 formula, the first thing we've got to do is to check our units and work out whether we need to do any conversions. The first thing I'm going to point out is that our time is given in hours, and if we're using the VT/dF formula, our time needs to be in minutes. So the first thing we have to do is to perform that conversion to convert 8 hours into minutes. One way of breaking that down will be to say 60 minutes in an hour, so 8 times 60 equals. You can do that in your head simply by removing the 0, multiplying 8 by 6 to give 48, and then popping your 0 back on the end. That actually works quite nicely as a shortcut for multiplication there. So now we've got 1,000 ml of saline to be delivered over 480 minutes with a drop factor of 20 drops per ml. We can now set up our formula. So we must have our volume in mils, 1,000, over our time in minutes, 480, which we multiply by our drop factor, which is 20 over 1. From here, as with the NHS1 formula, I always recommend that you start by cancelling down the fraction on the left-hand side. In this instance, we can immediately divide by 10 by taking off the zeros, which gives us 100 over 48. We can then use common factors or highest common factors to cancel that down even further. 148 are both even numbers, so we could cancel that down to 50 over 24. Those are again both even numbers, so we can cancel that down by dividing each by 2 to give us 25 over 12. 25 and 12 have no further common factors, so that side of the equation has now been reduced to its simplest terms. So we can set the formula back up in its simplest terms, which makes it a little bit easier to work with. We've got 25 over 12 multiplied by 20 over 1. Again, as with the NHS formula, we need to multiply the numerators together and multiply the denominators together. So our first calculation will be 25 times 20. Again, we can use mental arithmetic to do this. I'd suggest working out a nice straightforward one. 25 times 10 is 250. What we actually want is 25 times 20, and because 20 is double 10, we just need to double that answer to give us 25 times 20, which is 500. So our answer there will be 500. And 12 times 1 is just simply 12. That gives us a raw solution of 500 over 12. So now we need to work out how to turn that into a number that actually makes sense in the clinical context. As always, I recommend cancelling fractions down to their lowest terms. So again, we're looking for common factors here. Again, both even numbers. We can cancel that down to 250 over 6. We've still got even numbers there, so that can cancel down again to 125 over 3. There are no further common factors between 125 and 3, so this is what we've got to work with. Going back to division decisions, you'll remember that 125 over 3 is the same as saying 125 divided by 3. But again, as a method for solving a mathematical problem, that division number sentence is of very little use to us until we know what to do with it. And we're going to go back to my old favourite method here, bus shelter division, to work out how many times 3 goes into 125. As always, I like to put a couple of trailing zeros in the end, just so that I can work with my remainders and decimals quite easily without having to stop to think about them at a later stage. So, first question, 3 into 1 doesn't go. So I put a 0 up there. 3 into 12 goes 4 times. There are no remainders there. 3 into 5 goes 1 time with a remainder of 2. Don't forget to carry up your decimal point at that stage. 3 into 20 goes 6 times. 3 6s are 18, which gives us a remainder of 2 again. 3 into 20 goes 6 times, a further remainder of 2, which tells you that this is going to be a recurring number, 41.66 recurring. What we now need to do is turn that again into a number that you can actually usefully work with when setting a drip rate in a clinical context. You don't want to be looking at your watch and trying to work out 0.66 drips per minute. That's just simply not going to happen. So we must round that to our nearest whole number. To do that, we look after the decimal point, and our first number there is a 6, which is a number of 5 or above, so we will be rounding up in this instance, which gives us a final answer of 42, and always put your units in, 42 drops per minute. And that's how we use the VT-DF1 formula to solve a drip rate calculation.